Hi guys, I'm Jean-Romain from Scorp-io. I'm CEO and co-founder of Scorp-io, and what we do in Scorp-io is pretty much we do monitoring and control, but in the cloud. So today I'm gonna talk about building a robust MQTT architecture to scale across dozens of sites. We have taken a real use case we have addressed last year, but our own software is based on MQTT. So I'm gonna try to make you understand what we did and what main issue we faced building this kind of architecture, because of course our software is not across a dozen of sites, it's across hundreds of sites. So we had a lot of issue at scale, to scale. We faced that issue and we kind of succeed in facing this kind of issue. So I will try to give you the tips as much as I can. Okay, let's go. So I'm gonna talk about a Belgian company, which is one of our main customers at the moment, and they produce lime. And for people who doesn't know about lime, I will oversimplify it, but producing lime is quite simple, to be honest. Producing lime is the result of heating limestone in big oven like this one. So it's quite simple to produce, but you need a lot of energy to do it. So they face many issues. They have hundreds of sites across 25 countries. They have small sites with hundreds of data and big sites with thousands of data. They have multiple PLC, as you may know, and they have multiple of on-premise software as well as different machines. They have a lot of stuff. This kind of machine, they produce data, which they use a lot of different protocols. MQTT, for example, but they use mostly Modbus, as you may know, and they use also OPCUA, OPCDA, LoRaWAN, and other protocol they installed during the last decade. They have also some other software like ERP, like very very large ERP that it's complicated to get data from, and they mostly use REST and SOAP API to get the data from. So the customer, they went for us with this simple demand. So guys, we have 5,000 people in the company, and we want to bring the right data to the right person at the right moment. That was the challenge. That was the demands from them. The main issue they faced was they had this automation team. They spent like 50% of their time downloading data from the site and putting them to their colleagues. So it was like 50% of wasted time getting the data and putting them to the end of the right guy. So that was the main demand. It was to bring the data to the right person at the right moment. And to be honest, it's quite challenging because you have to face multiple challenges. The first one is it's the result of the architecture. It's not the architecture itself, of course, but it's getting a smooth user experience, user interface at the end of the project. Because you can have the best architecture possible. If at the end the user experience is poor, the software won't be used, and that's it, it's over. So for me, even if it's not the architecture itself, but more about how you're gonna build on top of that, you have to think about this first. And of course, if you have the best architecture possible, you will have also, I think, the best user experience possible. So that was the first challenge. The second challenge was also the real-time data. So Vincent talked about it. But you know, the customers, he comes to you, he says, okay, we don't need, you know, real-time data. But he said that he don't think about it. I mean, he wants real-time data. So so you have to deal with real-time data and not losing any data. That's why you need a robust architecture. You don't want to lose any data at scale. I mean, for one edge device to the cloud, it's quite simple. But when you have hundreds of sites, it's more complicated. You have to deal with store and forward. You have to deal with scalability on the top. You have to deal with scalability with your historian level. You have to deal with scalability on your data streaming, real-time data streaming level. You have to deal with transforming your data. And when you do all this functionality, you don't want to lose any data. So you have to take care about sustainability and scalability. The fourth is the maintenance and security. Okay, this kind of big company, they don't want problem with security. So the first step you put in the company, you have to be the best as possible about security. Because the more you're gonna put edge device on the company, the more is you are. I mean, there is a hole getting larger and larger if you don't care about it at first. Maintenance, of course. I will talk about it a bit later, but the last but not least is people and training. When you develop a software for a big company like this, you have to onboard people, because otherwise they're getting frustrated because they don't know how to use it. So you have it's key. People are key in this kind of project. And last, but I guess it's like our society now. Industry is like our society now. They want it now. Okay, I want the best architecture possible, the best user experience possible, but I want it now. And I want it to all my site, you know, in 1 year, please. So that's how it works. And you have to deal with it. You have to take the best decision possible to make it happen. So to start, you have to start to think about your edge device. I mean, edge devices are the key of your architecture. And to build this kind of architecture, you have to think global. That means you have to think first is security, of course, but the second is versioning. Versioning and security goes together. And for this particular problematic, you have different technical stacks. And one I liked very much was balena.io. If you don't know balena.io, it's quite impressive to use, because you centralize your operating system into one platform, and you can push update whenever you want. And believe me, if you if you finally do it one by one, you're gonna waste a lot of times. As well as configuring your firewall, for example. For simple stuff, it's quite a good technology. There is also some other tech, but I think you should try this one if you have this kind of challenges. Okay, we have talked about security. We have talked about version management. Versioning is not about only about your operating system. It's also about your application, your edge application. The way you're gonna get data from the PLC, for example, to your cloud platform. And you need to also take care about versioning and how you're gonna deploy to hundreds of devices when you find something better, or you correct a bug, or you just correct security. And for this kind of use case, we use, of course, our own software, but if you want to do it yourself with an open source software, I think you should use FlowFuse. FlowFuse is like the way you centralize your application, your edge application, to one platform, and you can deploy it in the same time to any of your devices. The third challenge is UNS. So UNS, we talked a lot about it before, and just I'm gonna go here. And here is an example of UNS we have implemented in this kind of use case. So you have, of course, the geographical division. Then there is also the machine, the time series sensors, and also the ERP information. So for me, to be honest, UNS is like asking your kids to clean their room, you know? So some kids, they're gonna just trash toys into a big box, but some others, they're gonna just, clean every type of toys in each small box, etc., to get it faster when they need it. So UNS is exactly the same. You can do pretty much what you want. The thing is, you need to think about when I need it, I want to access it faster. That's how you're gonna clean your data, I guess. So you have to clean your data based on your use case and the end user customer's needs. Otherwise, it's just cleaning someone over rooms, but without knowing how he gonna get the toys. So we made it like this, and it was quite based on the customer's needs. We have a lot of, we have studied a lot of what they needed to make it work like they needed. But you need to get your customers with you to make it work. If he doesn't spend time on it, it won't work. Because obviously he has the business knowledge to make it work. As a software editor, we don't have this kind of business knowledge. We just know how to build stuff, but we don't know how they're gonna use it in a real use case. So UNS, very important because it's gonna make your data work together on the cloud. So for me, it's better to do it on the edge, of course. And UNS is not only about cleaning your data. There is two notions which are very important. It's sampling and hysteresis. Because believe me, you don't want useless data on the cloud. And to get rid of useless data, you have to fix sampling and hysteresis the best way as possible. Otherwise, you're gonna be flooded of useless data, and useless data is a mess at the end. Store and forward, I will talk a bit more about store and forward because it's also key when you talk about distributed architecture. And the last one is monitoring. You need to monitor your edge device. Without your edge device, the top won't work. So you have to monitor your edge device as well as the machine, the same way you monitor the machine. Otherwise, it won't work at all. And I guess that's it. Okay, let me explain an example of an architecture we made for an edge device. So on the left, you have the level 1 edge protocols, which are pretty much classical. On the middle, you have the UNS microservices that cleans the data. As I said, it cleans the data because there is a template for each machine you're gonna connect. Template, you made it on the cloud and you pushed it into your edge device, as well as the sampling and hysteresis, which are very, very, very important, as I said before. And okay, some people say, I mean, MQTT is not as good as for store and forward technology. I mean, if your broker is not on the edge device, I don't get how you can do store and forward with MQTT. So for me, MQTT goes with Kafka. Kafka is kind of complicated, but it's very, very powerful. If your backend services are cities and MQTT are the road, then Kafka is the highway, you know? You have to pay for it, but you can go faster on the third lane, but also slower in the first lane. So I think it goes together, to be honest. I'm pretty sure now it goes together. So you have Kafka in the middle to pub sub. That means if you break this link, everything goes to Kafka and wait. Then synchronize when you get back the link. It does work, and it does work well because we did it in hundreds of devices, and we depend, of course, of the bandwidth and other stuff, and it works well. It was one of the best decisions we made because we have tried like SQL Server or any database on the edge device. It's quite complicated to make it work as well as Kafka works. And I'm also MQTT Spark-plug-B maximalist. So to publish the data to the broker, which is a scalable broker like IVMQ, we use MQTT Spark-plug-B. I have a ton of story about MQTT Spark-plug-B, but I don't know if I got the time yet or not. Anyway, why MQTT Spark-plug-B? Because, of course, the birth and death mechanism is very powerful. Also because MQTT light bandwidth, of course. And what can I say? I have noted some stuff. Yeah, the single source of truth is very powerful, of course. But on the top, you have a scalable MQTT broker. Why we made it scalable? Because when you build a software like we built, we don't think about, you know, there will be 100 devices and it's fine. We think about thousands of devices connected. And not only MQTT Spark-io edge device, we meant a lot of use case using classical MQTT or any other technology. So we think about, okay, we don't want to be close to like 100 devices and that's it. We have to recreate a broker, a new broker with new address, etc., etc. So we went to a scalable broker with there is a lot of issue to it, but we faced with this issue and we have made something very scalable. And on the top, you have on the left, of course, the MQTT broker, and here we go again, Kafka. Kafka in the middle. Kafka is like the backbone of our cloud solution. That means you get data from each microservices with Kafka. So you get you get, of course, standard data from it, because you have, like you can see, the MQTT source connector, but we have also a ton of connectors which are not MQTT, obviously. It could be REST API connectors, SQL, JDBC connectors, and any connector which connect to Kafka. Kafka is like a toolbox, so it's quite powerful. And every message is going through Kafka and goes to each microservices. We have like real-time data streaming microservices, historian, of course, data services, and transform microservices, because even if you deal with clean data, you want to transform it sometimes. You want to add alarms. You want to transform data to get use case on it. So you have to get you have to get one microservice to transform the data before sending it to the historian or to the real-time data streaming. For the scalable historian DB, of course, there is multiple technology, I would say. It depends, to be honest, it depends for the skill of the team. If your team is more about SQL, you can choose the timescale DB, which is great. But if you prefer InfluxDB or NoSQL, I mean, it's up to your team and what we are good at it. Because I mean, timescale DB, InfluxDB, or Warten, which is a French database provider, is kind of great. So don't bother to challenge, to benchmark too much this kind of technology, because they are good. So in this kind of architecture, you have to think about when I have a microservice who's gonna get down, how I'm gonna deal with a message. So you have to think, as I said before, you have to think to not lose any data. Because if you lose data on the if something goes wrong and you lose data, your customer's gonna go to you, and it happened to us, and say, okay, I have no data during this time, what happened? And yeah, you are facing scalability issues then, and you have to work on it. So we use, to scale across thousands of sites, we use Kubernetes, which is a bit like Kafka. It's expensive at first, but very, very powerful. So basically, it makes your microservice resilient. That means, for example, if I take this microservice here, he does scale with the charge on it. So if there is a lot of people working on it, it's gonna scale until the charge is fine. then it's gonna downscale until the charge is gone. Even if it fail, another pod gonna pop up and it will work fine. And this make your architecture sustainable and scalable. Otherwise, you just have trouble with losing data. And Kafka also is very sustainable because if he doesn't deliver a message, then the message stay in queue and it's fine. Okay, the results from these typical customers is after 8 months we have deployed like 10 sites, which was great, to be honest. And after 12 months, 20 sites was deployed. And this year we aim to deploy all sites around the 25 countries they operate. At the moment, we have 100 active users, which is a lot for monitoring and control systems. And it's I'm quite proud about it when I check, you know, we have some software to monitor what does our customer on the software. And when we check and there is like 20 or 20 people from this company working on it, we are quite proud. That means it's working well, and we have very, very good feedbacks. And the two sentences here, the first one was, you know, the use case, the address at first was monitoring the pollution into the air. It's quite, it's quite simple as a use case. But after a few months, they have made their own use case, and now the use case they work on is the energy consumption of each cycle of industrial ovens. That means high value use case, because when you deal with that, you deal with millions of dollar capabilities, functionalities, because it's not the same use case, and getting this use case to this use case is really, really great. That's why what I meant is they started small and now they think big because they have the tool to do it. So when you provide the right tool with the right user experience, you can expect the right use case. Thank you, Kozai, to let me talk, and I thank you to let me talk to this kind of event. Sorry for my English, it's not that good, it's not, but I did my best. And if you want to talk with me in French, of course, I would be proud to explain it better in French. If you have some question, of course, you can.
How are you able to scale so quickly across sites? The data was already available for the SCADA system. How was it possible? 20 sites in 12 months.
Yes, there was already like PLC was fine, and we went fast because we have like a plug and play solution. We try to make it work. Each site is 1 day of deployment. So we have made the template quite fast with the customers, because the customers, of course, they worked on it before, and the deployment was quite simple to do. And we had the tools, we have the software. It was just a matter of 1 day for each site.
They were very standardized then. PLC data was very standardized. No.
Not really, but the data table was fine. You know, they had the data tables. We met some industrial people. They don't have the data table, which take longer, of course.
Okay, one question. So you mentioned you have 100 active users, which is awesome.
Yes.
Could you maybe tell a few words about like who are those users, how they're using the platform? I'm curious.
Okay, we have different kind of users. We have like process users. That means they connect to get data from the oven and work on it. We have also operational users. They try to understand why the production, you know, if they produce are fine or if they are late. We have also like managers. They want to know the OEE of the oven, for example, or top 5 default, stuff like this. And we have also automation teams where they need to get data, you know, to repair stuff. So it's another use case, but they have their own interface. Monsieur là?
Yeah, since we're talking architecture, to what extent do you reckon that the capabilities of modern brokers in order to do data transformation in the broker itself would be able to simplify this whole architecture by eliminating the external microservices and do it internally in the broker systems themselves?
Yes, it's a good idea, to be honest, but the thing is, we don't have only MQTT data. We have also a REST API from other cloud systems, and we have other information, a lot of information, to be honest. So that's what we had to make it after the Kafka technology.
Separation of concerns.
So I just have a question about those gateways and the architecture that you showed. First, for me, it's understandable how Kafka works in the cloud. But is this a gateway that you're putting Kafka on the gateway, or?
Yes, a small version of Kafka.
What are those gateways actually? Those are industrial gateways?
You mean the device? It could be any device. This is the software we put in hardware, in any hardware, to be honest, with Docker. It's Dockerized.
And my question is, why do we need Kafka there? Because MQTT has a quality of service assurance, so that when you are disconnected from the broker, you will store locally the messages that you can then send when the connection is established again. So I don't see the need for Kafka, except that, it's very heavy weight to be on a modest industrial gateway.
To be honest, we have tried with only MQTT, but it was not working as we seems. Maybe it's our fault. Maybe we didn't push the test further, but I think it was not the right things to do when you talk about thousands of data. We had some issue to it, so we just changed our. We we have to learn about MQTT again, but about Storm Forward, it was not working well as we expect.
Yeah, so that's what I try to understand, because the lightweight nature of MQTT coupled with the quality of service assurance that you can store locally the messages when your device is disconnected, which is the most often problem with those gateways, can guarantee that you can connect those gateways only via MQTT and remove a heavy weight Kafka in between, because Kafka is a hell to maintain. The zookeeper that you need to build a cluster, stuff that you need to put even a simple Kafka client on the gateway. So for me, this is like a really kind of overkill for a simple industrial gateway. That's one. And the other, so I see really the benefit of having a Kafka client on the gateway, or Kafka Lite. So append only log client on the gateway when you need to assure not to lose any message. But again, MQTT does it, and there are more lightweight solutions like Redis streams or some other stuff that can guarantee that you store messages locally, that you can do the reply of the messages as well.
There was another things what we choose to put Kafka in the gateway. It was to also unify data to the same tech, you know. And if we had like Modbus and even some SQL data or any flat file data, we could, you know, put them unified into the Kafka tech. That's why we also use Kafka. But yeah, it's easy, as you said, but we don't use, of course, the keeper and stuff like this on the edge device. We use a lightweight Kafka tech. So yeah, probably it would have worked with MQTT, but we didn't push forward the test. So I cannot tell you if it would have worked the same way we did. Yes, Mark.
MQTT by your user in that case. I have two questions. They have 25 sites, you said?
Yes. No, 25 countries, 100 sites.
So
Yeah.
100 sites. And why did it take so many time for them to figure out they have to use MQTT for their solution? Is it something you explained to them, or they knew it and they asked you to do it for them?
Funny things, when they went for us, they said we don't want any cloud solution. I said okay, but we can do so let's try. We said okay, but let's try one site. We tried. They said okay. I think we're gonna choose the cloud solution. No. I think it's a matter of person. To be honest, it's not about matter of company. It's a matter of person. The person say okay. I mean, why would I choose otherwise? Because it seems to be the best fit. So let's go.
Hey, Jean-Romain. I have two questions. May I ask two questions?
Yes.
Okay. First question. On the edge side of things, what made Balena the obvious choice for you?
I mean, it's not the obvious choice, but it helps a lot. Because, I mean, it's not cheap, of course, but it helps you to go to operational effectiveness, you know? Because you control your device. When you have the control of your device, when you have the control of your security, I mean, you are powerful, you know? So it's a tool that makes you powerful. So that's why I like it. But it doesn't bring any value to your end customers. But it helps you to level up your game.
Okay, all right. But compared to other options?
Other option, to be honest, I don't know any. I mean, I made a few benchmarks, but I don't remember them. I don't remember. But I made it like there was another. Which software you think about?
We can talk about that later. But
Okay.
I wanted to know what you had chosen, right?
Yeah.
It's not what I think; it's what you think. No, like in terms of the choice. So anyway, let's go on the first question. Second question, which comes back to the overall architecture. So it's good to see the data plane. So this is the data plane in your system.
Yes.
You also have two other planes. You have your control and your management plane. So for infrastructure, Balena and their tooling is okay at the edge, but
yes.
Control and how you actually then deploy configurations in order to make that UNS work end to end.
So we have multiple infrastructure in our own software. We have like the production infrastructure which lead to this kind of stuff. And we have also operational, we call it operational technology. For example, for the end customers, we have Balena, for example, FlowFuse, if he wants to get the end to the template. We have also our own stuff to make it, to push it into the edge device. And we have also ChirpStack, for example, some tools to deal with LoRaWAN or any other protocols, IoT protocols. And that make the, when we provide the service to the customers, it's we want them to have a full included, And in this full included, there is the operational software as well as our main core system, which make us live. I mean, our production system and supervision and control, monitoring and control cloud systems.